Welcome to Equals Math Instruction and Support for Students with Moderate and Significant Needs. I am Karen Ross Brown from AbleNet. I will be providing you with information about the lessons, focusing on students who require concrete objects to understand math and adaptations for communication and motor skills. In Equals terms, this webinar is for teachers who have students needing Level 1 support and some students who require Level 2 support. Essentially, I'm talking about what is necessary for students to be active learners of math. I was the original writer of Equals and co-writer and developer of the revised version of Equals Math. I brought 23 years of experience to Equals for students who have traditionally been left on the sidelines of math instruction due to the lack of availability of an appropriate math curriculum with adapted rigor that would meet their needs and raise expectations. We made sure we provided opportunities, materials, and hundreds of adaptations so all students can be active learners of math to the best of their ability. As you know, expectations are adjusted for students with moderate to significant needs, but at the same time, there's an increase in expectations from what has been expected in the past. So let's think more about instruction before we dive into access to that instruction. We know that learning happens when students have models and examples to follow. Models are often missing from math class generally, but surprisingly absent from special education classrooms as well. I tend to think this comes from the focus on data teachers are asked to collect, and certainly it is important to collect data. However, students with disabilities need the bulk of their education focused on learning. They need to see what it looks like. What you are asking of them? I continuously hear how happy students are when they know what to do in math class, have manipulatives to make sense of what they are doing in math, and are part of a group that learns together. I have heard about and observed students using Equals show confidence, excitement, competence, and persistence. Learning happens when students use language to understand, talk, and think. And many students need support to do this. This means they may need access to a device or communication system that has been chosen for them, but they also need a way to talk about the math they are engaged in if they do not have messages on their devices that are necessary for talking about math. You will see how to use lesson materials to enhance communication so students can talk during math class about what is happening now in the moment. Learning happens when students connect new information to what is known, made possible by the design of Equals lessons and the order of the lessons. So it is very important to stick to that order. Learning happens when students engage in activities that active learners do, to basically do something, observe the result, and talk about it. Working together in a shared experience with the means to talk about it is fun and engaging learning. We also must remember that students learn over time when their knowledge is connected to what they know. Let's think about it this way. To ensure students are learning, make a commitment to the idea that all students are active learners who observe, think, act, and talk about it. If we start there, the next thing to do is to give some thought as to how to make that happen. Before you teach a lesson, ask yourself these two questions. What does learning look like for my students in this lesson? And how can I make this happen? When you think about teaching in this way, you begin to create opportunities for students to reach their potential. Essentially, you are raising expectations and are ready to support that effort. Let's take a look at 7 access strategy basics. These are ways you can support your students to reach their potential. The methodologies written into every Equals lesson is based on best practice from general education. Basically, these methods are research learning strategies we all naturally use. It's how our brains work. We all learn by connecting new to known information, and we learn over time, which is why we have equals lessons placed and taught in a very specific order. This is the same for all students, including students with disabilities. However, students with disabilities must have access to such learning. They need material presented with models and at a slower pace with less language used to process the information. They need a way to communicate and move things around on the table. Often they are concrete learners and have limited life experiences. However, once we take that into account and provide necessary access, students with disabilities can and do learn math. This is how we provide that access. Access strategy number 1, reduce the amount of your language. I will use an example from lesson 1A1. Student will attend to math instruction. The very first activity of that lesson, vocabulary review of the word look. Now this is the first lesson in equals, so there wasn't a lesson prior to this one to be able to review the vocabulary in that way, yet the students have had plenty of opportunities to hear the word look at home and at school. Let's see how we can reduce the amount of language in this activity without compromising learning. This is the very first activity of the lesson, vocabulary review. The word that is being reviewed is the word look, as written in the lesson. Student will attend to math instruction. This is directly from the teacher's guide itself. It says, show words, read together, say, look means to see with our eyes. We learn by looking. Sometimes we learn by looking and touching. Pass mirror around the table so students can look at themselves. Make concrete connections with students. Fasten look pick symbol to plastic mirror. Say the word look. I can look at myself in the mirror. I can look at you. Look at each student. Say, look at me. Wait for each student to look at you. Look for examples in classroom or poster. Show meaning with materials. Ask, how can you show me what look means? Students take turns showing the meaning by looking at something. So generally, that's what I would use for students at level 2 or 3. For students at level 1 and some students at level 2, I would break this down to the essence, slow it down, make the interaction as concrete and interactive as possible, and repeat. It's important to remember what this is for. Students understanding the word look and engaging in looking when learning, right? Students will attend the math instruction. No need to feel bogged down by what you see between the quotation marks in the lesson itself. It's not a script. We wrote the lesson that way to make it simpler and easier to get to the gist of the lesson component. It is for you, not necessarily for your students. The descriptions and language in each lesson activity gives you the basics of what this section is about. Break it down as you need to, but it's always important to keep all math terms, vocabulary, action words, and math tool names as is. These are all repeated throughout equals, and consistency in the use of these words is key. You can use simpler words to describe the vocabulary or action word, but not replace it. Think about the essence of the activity and the reason for doing it. In this lesson, we want the student to learn to attend to math instruction by way of exploring math tools. Learning the math tool names is not the objective. We want to provide interesting experiences and manipulatives to engage students. So essentially, we want to break this down, go slowly, get students involved, and repeat. Okay, so what you're seeing on the screen is what I just read directly from the lesson. And here's an example of how I would present this to my students at level 1 and involve them throughout. So I would first show the word, and I would say, look, this word is look. I would point to my eyes and say, eyes, these are my eyes. And I would show that to each student. I would say, find your eyes, and I would help each student find their eyes. I'd show my eyes again. I'd say, I look with my eyes. I'd show the word look and identify it. Look. I would record look on the step-by-step communicator. I would point to the card and move the step-by-step communicator to each student to repeat. Look. Show the plastic mirror. Say, this is a mirror. I look in the mirror. Model looking in the mirror, then show each student and direct each student to look in the mirror. Ask a student to fasten the pick symbol or the look card on the mirror. Assist as needed. Repeat reading the word again, taking turns with the step-by-step communicator. Show an object or objects of interest to the students. For example, butterfly counters on the black tray. Look at it. Say, I look at the butterflies. Look. I'll show it to each student and say, look. When the student looks, say, you looked at the butterflies. You can do this with your students. It's remembering, break it down to the essence, go slowly, get students involved, and repeat. Essentially, I did what I read that was directly from the lesson, but in a way that had fewer words and got right to the point. And that's essentially what we need for students at level 1 and some students at level 2. Access strategy 2, levels 1, 2, and 3 have differentiation built into the lessons and the materials. Here is an example of a worksheet for level 1 support and an additional support using concrete objects. There are 3 types of worksheets and lesson tests that are provided at 3 levels of support, as well as support directly embedded into the lesson. This is an example of a problem-solving worksheet at level 1 that directly connects to page 3, Solve It, as a way for students to record the solution. For students who are concrete learners, I would be sure to bring in concrete objects to support understanding. On this worksheet, students are asked to find the math tools on the page. Although there are images of the math tools here, I would bring in the actual math tools and place them near the image. The students, with your help as needed, can circle the image and matching tool. Then you can remove the tools and the worksheet can then be sent home or saved in a portfolio or displayed, or take a photo of the page with the tools circled. The third access strategy is to provide access to communication and actions in the moment. Students should have their communication system with them at all times. If they do not have enough message locations to include math language linked to a lesson, you have an additional support. Materials the students are using in the lesson. You can give answer choices using lesson materials for the students to choose. Place 2 or 3 choices in a display and students choose by pointing, touching, or eye gaze. The red place value chart, as you can see in the upper right-hand corner, is in your equals materials and is meant to be used as a pocket chart so you can hold up 2 to 3 choices with one hand. If the student cannot point, touch, or eye gaze, record, that's the one I want, on the step-by-step communicator, and you do the pointing. In this way, all students have an enhancement to their own devices as needed to talk about what they are doing in math class right now in the moment. For access to actions, the Action Dictionary is an important source of adaptations for language, motor, and vision challenges. There are 3 action cards demonstrated and used in every lesson. It is a very important part of problem solving. The words show, look, and touch are the action words used in this lesson 1A1. On the first page, starting with Math Dash, you are reminded 4 times to demonstrate each action, name it, and pair it with the visual on the action card. Students should try the actions as well. You will see this reminder on all 4 pages of every lesson. The action cards are directly connected to the 2 problem-solving strategies in each lesson. Practice with the action cards allows students to have advanced knowledge of possible actions when they get to the point where they are asked, while problem solving, what will you do to solve this problem? Students then have 3 actions that they know that they can choose from. The action cards also draw attention to the cause and effect connection in math and problem solving. At the top, you see the action cards listed in red. They are the first consideration for adaptations if needed, as they are linked to the problem-solving strategies and will allow students to engage in the actions when they are modeled throughout the lesson. Next, I identified the common student actions present in all lessons across equals, as you can see listed on the left-hand side in purple. This is a good place to continue thinking about what your students can do and how to adapt the actions, if needed. Sometimes action words are a part of this list, as is the case in this lesson. For actions not yet adapted, hand under hand is a good temporary way to help students understand the movement associated with the action until an adaptation is in place. When you are just starting, you may want to focus on adapting the action word cards first, and then perhaps this list, since action cards are linked to the problem-solving strategies. Choose 1 or 2 actions to adapt per lesson if an adaptation is needed. Later, start to add more as you move to new lessons. This is page 2 of the lesson 1A1, and this is an example of the role actions and action cards take on in the lesson. 3 action cards for this lesson are show, look, and touch. An example of the reminder to demonstrate the action cards is here. And the inclusion of one of those cards in this lesson, the word look, in the problem-solving strategies. Note that while the problem-solving strategies are informally shown on page 1, this is the first time they are formally modeled here on page 2. If you are looking for the strategies to know which action card or cards to adapt, look to page 2. The problem-solving strategies are the only text underlined in the entire lesson. For this lesson, the action word look is part of both strategies. If your student needs assistance with the action word look, use what is already established for that student or look to the action dictionary for ideas. Here are some ideas for adapting the action word look so students who need it can more easily access the action and participate as an active learner in the lesson. There are 2 pages of ideas for the word look. If your student needs support for looking at an object, you will find adaptation ideas here. For example, using a Big Mac to ask, "Can I see?" Or anchoring an object on 3-ring binder to use as a slant board. Perhaps the student needs to light the object to see it, so a battery adapter connected to a flashlight and a swish may be considered. Or framing an object or image with a focus window will direct the student's attention to it. These are adaptation ideas for the word show. For the word touch, with cross-referenced adaptations to the words explore and hold. If an action word, such as the word touch, does not have its own page, look in the table of contents in the action dictionary for cross-references. Access strategy 4. It is essential to make learning for concrete learners as concrete as possible. We can include making choices using math tools and materials to express a thought or answer a question. If I use lesson materials in a display of 2 or 3 objects, there is an instant connection to what we have been using in the lesson. The materials on the table are used by everyone in the group, so the objects quickly become a link to a shared experience. You can also just keep the materials on the table for students to use to jog their memory or to help express a thought or example. We can take this one step further and directly connect it to show and tell on page 1 and to problem solving, where students can use objects paired with key facts to answer questions when solving a problem together. Although all students should have their communication devices near them at all times, sometimes there are not enough messages locations available to talk about what is happening in math class in the moment. Remember, students who are early language learners and need language support benefit from using lesson materials to make a comment, answer a question, and make a choice. This is an example from page 1 for show and tell that includes both teacher and student answers to the questions using the number notes poster. Again, the concrete objects and materials can be placed on the table, or if you want to narrow the choices, make a display of 2 to 3 choices for the student to use to answer a question or make a comment. This makes for a very user-friendly, simple, and structured conversation about math. In addition, you are modeling the conversation. All of the tools and materials are on the table. The students have already seen and used them. This is a conversation about a shared experience. Basically, this conversation has the same structure in every lesson, just with different topics as the teacher and students say what they know and want to know about the lesson objective. In this lesson, what I know and want to know about math tools. Let's look at specific examples of using concrete materials when problem solving. The problem in this example is written on both sides of a pocket chart easel using sentence strips to write the problem. Of course, I had to reduce the problem to the facts so it fit on the easel, and more importantly, so it gave students less irrelevant information to process. I wrote the basic narrative on the front and the question on the back. In this example, the objects in the problem are attached above specific words with tape. So you can see ocean and insect counters are supported with ocean animals from the equals kit and insect counters from the equals kit. A box is also shown in the problem. However, that's just too big to tape to the pocket chart, so I just set it on the side. The problem is Beth works at the school store. She got ocean and insect counters in one box. So we'll just focus on the front part of this and not the question. 3 sets of objects can be provided on the table as answer choices: ocean animals, cookie shapes, and insects. I can ask my students, what are the facts in the problem? Or what kind of animal counters did Beth see in the box? Students answer by talking, using a communication device, touching, pointing, or eye gazing to their answer. Or I can record that's the one I want on the step-by-step communicator and I do the pointing. I am sure to respond to any answer attempt by confirming the choice and framing it in the context of the problem. For example, if I ask the student to choose a fact and the student chose insects, I would say, yes, you chose insects as a fact. Yes, Beth saw insect counters in the box. That is a fact. If cookies were chosen, I would point to the objects taped to the problem and say, I don't see cookies here. I see ocean animals and insects. Point to the other choices on the table. Say, tell me about a fact in this problem. Another way to do this is just use the objects on the problem itself and have the student choose from there without choices on the table. This is a similar setup. In this problem, I added a card, as you can see. to represent the word pictures in the problem. Paloma is labeling pictures of pond animals. She counts to 10 for the ink to dry. Here, pond animals are represented by a turtle and a dragonfly. I provided choices for the problem facts differently here, with 2 choices that are correct. You can provide the choices as you see fit, depending on your students' goals and current knowledge and amount of support needed. For example, if a student is just learning how to make choices, I might make the choices errorless. Strategy number 5. It is very important to model what you want your students to do, even if it means giving away the answer. I am referring particularly to think about it on page 2 of the lesson, where you demonstrate solving the problem with each strategy. Concrete learners need to see what you are thinking as you solve a problem, making it as concrete as possible. I will be showing you an example of this as we walk through portions of lesson 1A1. Access strategy number 6. It is in the student's best interest for you to move forward with the lessons in order without skipping, so students can build their learning and vocabulary with prerequisite skills. This is easily done by following the lesson order. Each decision that went into building the lesson structure was best practice instruction based on learning and brain research. Prerequisites are a good example of best practice instruction. When we learn, all of us connect new information to what we know. This fact is behind the idea of activating and building background knowledge. It is the reason we created the equals lesson order with concepts divided into smaller parts, which are introduced lesson by lesson. This process allows students to learn in smaller chunks with more practice and something to which they can connect what they learned in the next lesson. Finally, access strategy number 7. When students understand the role of cause and effect in math, and especially when it is connected to problem solving, they will have a more active role in math, especially when choosing and using tools correctly or choosing an action to solve a problem. Babies learn when they cry, they will be comforted, changed, or fed by their parents or caregiver. A baby is beginning to understand that crying makes something happen. It is the first lesson of cause and effect. When I do something, something happens. You might have worked on cause and effect with your students, connecting a switch to a toy, or music, or rolling a ball back and forth, or even knocking down a tower. All of this is information about how things work in the world, and that knowledge is valuable when learning math, because cause and effect is everywhere in math and becomes particularly important in problem solving. Here are some examples I pulled from Equals Math. We will be looking at these as examples for students to begin to experience how cause and effect works in math and support the problem-solving process. I'm not necessarily using the words cause and effect with my students. Rather, I am showing them how things work in the world and also extending that idea. It is good to try things and learn from the experience, and if it doesn't work, try something else. This example of cause and effect in math is sorting objects by the attribute of color into sets. The cause is sorting one set of shapes by color. The effect is there are now 3 sets, not one, and each set has one color. This cause and effect example is using cubes to make a new shape. The cause is stacking 4 cubes on top of the other. The effect is one shape, a rectangular prism. You can extend these cause and effect experiences by asking questions to guide students in thinking about it in a new way. I have a choice of 3 objects on display: a hexagon, rectangular prism, and a butterfly. I ask the question, which do I use to make a tower? I would give an example, especially if this was a new activity for the students. My example is, I will make a tower with butterflies. My reason for doing this is to show students that I can make a choice and try it, and if it doesn't work, that's okay. I can try something else. Students can see it is okay if I make a mistake, and I can show them how to turn it into a learning experience by trying something else. It is very beneficial for students to have both kinds of experiences, as it helps them see how the world works. After the butterfly tower is completed, and it doesn't look like a tower and probably falls down, it's time to try a different way. It's also an opportunity to talk about the importance of a unit. It makes a difference when we make a tower with blocks and not butterflies. What happens when I count 5 turtles? I have a set of 5 turtles. The cause is counting 5 turtles. The effect is a set of 5 turtles. In this case, when I ask, what do I use to make a set of 5 turtles? I'm focusing on the importance of the unit when counting. When I count a set of butterflies, do I end with a set of 5 turtles? No, that's how the unit matters. In this example, I am decomposing and composing a set of 5. There are multiple ways to do this task, and we learn each way works. I can extend this activity by asking a different kind of question. Which sets do I join to make a set of 5 turtles? Students can answer, then try it out to see what happens. If it doesn't work, if we don't end up with a set of 5 turtles, let's try something different. A general understanding of cause and effect is when I do something, something happens. This can happen in any environment in a wide variety of ways. We learn this by experience. It's a good reason for students with motor challenges to have adaptations in place. It adds to the learning experience when we pair an action with an effect. We remember better when we do it ourselves. Language comes into play when we talk about what happened. Using concrete materials to represent outcomes, then choose the outcome we saw happen, is very helpful when students do not have enough message locations on their devices to talk about it. That's where the choices come into play. If a student is able to talk about what happened with a verbal voice, a device, and/or by acting it out, that's good too. In math, what we do with cause and effect is more specific. Instead of when I do something, something happens. In math, it's when I do this specific thing, a specific thing happens. For example, when I do this, count 5 turtles, this happens. I have a set of 5 turtles. Then we talk about it. What happened when you counted 5 turtles? Did you get a set of 2 baseballs, a set of 5 turtles, or a set of 5 cubes? There is a way to get parents involved in this process as well. There are 2 parent videos that show parents how to guide their child in everyday problem solving that encourages thinking and trying problem solutions. Part 1 is essentially an introduction to the problem solving process with everyday chores. Part 2 is more closely aligned to math concepts. Take a look at these and decide for yourself if you would like to share them with parents. Lesson 1A1, student will attend to math instruction. This is the very first lesson in Equals. For that reason, I would expect to provide the most support so students will know what I'm talking about and what to do. It is always important to stay focused on the lesson objective. For the earliest lessons, the lesson objectives are about engaging the student, no matter what the activities are. Engagement is the goal. Attending to materials and exploring and touching them. We've already covered a vocabulary review for the word look, so let's move on to the game. The game on the first page of the lesson is typically a game from a past lesson. Since this is the first lesson, this game was written so the students could interact with each other and see something familiar, their photo. The alternate spinner is used here. You can flip the overlays that come with the spinner. Simply flip the larger overlay. You can attach angle eggs or wax-coated yarn sticks to make dividers. For the inner overlay, turn the clear cover until you can pull it out, and pull this arm straight out and flip the small overlay. Replace the arm and plastic cover. This game focuses on matching the photo on the spinner to the students in the group. Player spins. Everyone looks at the photo selected, and you say 1, 2, 3, look, and everyone looks at the student. You can adapt this game if necessary. For example, use larger photos than the ones you see here and match up each photo with each student. You can make copies of the photo and place by each student if you'd like. When the arm stops, you can take the photo off the spinner and hold it up to the student's face and say 1, 2, 3, look. There is an option you could try as well. Place a favorite object near each student and a photo of the object on the spinner. And then 1, 2, 3, look at the object. Math Dash is the next lesson activity. Before we begin, you are reminded here the action words are introduced. The words are show, look, and touch with cards to match, which need to be paired with the action itself as the word occurs in the lesson, or you can take time to show them as part of a daily review. These are the directions for Math Dash in the lesson. Show one familiar object. Say, I look with my eyes to see, and it's the object name. I can show it with my hands. Show remaining familiar objects. Show how to look at and touch them. Students look at and touch objects. Ask open-ended questions. How can you look at and then the name of the object? How can you see your friend? How can you learn about? And students answer. Most of the directions here will work as is for students with significant needs with some tweaks. The main adjustment here is to slow down and remember processing time. Students will need time to process what you are saying and process a response. Start with counting to 10 in your head, then adjust from there as needed. I placed the concrete connection for look and the step-by-step communicator on the table, so vocabulary is supported. Show one familiar object. There's the word show. There's the object. So here's my time to demonstrate what the word show means. Say, I can show the book. I look with my eyes to see the book. I can touch it with my hands. So as you noted, as I was going through, I was using the action cards of show, look, and touch as I stated them. And I would certainly make those prominent as I'm talking about those. Have the students try that out. Show remaining familiar objects. Show how to look at and touch them. Students look at and touch objects. And follow the rest of the directions as written. However, when you get to the questions, use statements rather than questions. For example, instead of, how can you look at the paint? Say, look at the paint. Or I can pair the question and answer. How can you see your friend Leah? Look at Leah. We've moved from the first half of the first page, mainly activating background knowledge. This is Explore and Connect. You are teaching students to build their background knowledge so they have familiarity of basics before page 2 when problem solving is modeled. In the first part of Explore and Connect, students become familiar with a people or animal environment. School was chosen for chapter 1 because the students in chapter 1 are just starting out and they are actually in this environment, so they can more easily relate to it and make sense of the idea of an environment. And that will be used as context for solving problems later in the lesson. The poster cards directions are the same in every lesson. You can slow this down and add objects to the process as possible. These directions are written in a flexible way with ideas to make math connections to the real world. You can adjust that to fit your students' needs. For some students, especially with unfamiliar environments such as rainforest, you may want to show a National Geographic video. Here are the written directions as part of the lesson. Show poster cards. Discuss what you see on the poster and cards and personal experiences. Look at object or picture from school, internet, book, etc. Locate items to look at on poster and cards. Point out math tools. This activity helps students see the connection of math to the real world. It also provides background information about this information when students solve a problem in this lesson set in this environment. This is an opportunity for students to talk about what they see and explore, and by placing a concrete object on top of a photo or holding the next to the photo gives students a view of concrete and semi-concrete representations. Poster cards to the right of the poster help students focus on or see one item at a time with close-up photos from the poster. The cards can be used as choices to assist students in talking about the poster. Actual objects from the school that are on the poster, such as pencil cups, markers, pencils, ruler, paint, and a lunch tray, plus materials from the kit, flying disc, math line, and anglix constructed into shapes, cubes, and cookies can also be used to locate pictured items on the poster and or provide a concrete way to talk about what is there. I can use a display as you see at the bottom right. I can point to a tool on the poster, for example, the math line at the bottom here, and ask which math tool is this? Students can answer by indicating with pointing, eye gaze, or touch to the answer from this display at the bottom. Remember, if a student is unable to do those things, record that's the one I want on the step-by-step, and you do the pointing. The next activity, Math Tools, portion of Explore and Connect, typically features tools students use for understanding the problem-solving strategies in the lesson. As students are taught to attend by looking, touching, and talking about the tools, real tools from the kit are provided. In this example, the teacher begins by showing what to do with the math tools by stacking the blocks. Repeating this with other tools means the teacher will show what you can do with the other objects, such as slide tabs with attached cubes on the math line. And then touch, examine, and sort the shapes, for example. Then students explore the tools. Are the students learning to make a tower or count or sort in this lesson? No. The objective here is student will attend to math instruction. Counting, sorting, and stacking are examples of actions which are part of math instruction and hopefully will get the students interested in attending to what's happening. These are also great examples of cause and effect. In show and tell, model what you know about math tools, showing, looking at, and touching them. Provide a display of math tools and action words, show, touch, and look, to use. Ask, what do I know about math tools? Then show how to answer and record it. For example, I know I can touch math tools, and fasten them right to the number notes poster. Ask students, what do you know about math tools? One student might choose the word look, or the math line, or both. Reinforce that choice and record it on the number notes poster. For example, Yes, you can look at the math line and place the math line on a surface nearby the poster. Another student chooses blocks. Move and make a tower with blocks and maybe place it nearby with the word show to emphasize the action of showing a tower and say, yes, you know we made a tower with blocks. I can show a tower I just made. The next question is, what do I want to know about math tools? Place more math tools on the table, or just use the ones from the lesson. Answer first to model a response. I want to know, can I explore the ocean animal counters by touching them? Then ask, what do you want to know about math tools? Or you could ask, which math tools do you want to explore? As students answer, record using the actual items on the table fastened to the poster. On the second page now, you'll begin with new vocabulary. In this case, it's the word math. Show the vocabulary card. We want students to have a visual and concrete examples of what we use in math class. There are shapes, cubes, and numerals on the table. Read the definition, then students help you create the concrete connection. And label it with a lesson pick symbol, or you can label it with the lesson vocabulary card. The directions also include additional math tool examples with lines, numbers, dials, and buttons. For example, math line, scale, ruler, calculator, etc. After new vocabulary is introduced, we move to think about it. This activity is a demonstration of problem solving using one strategy, then repeating problem solving with the second strategy. Look at the solve poster questions in the upper right-hand corner. Now look at the numbered sections of this activity. You will see there is a description and example for each of the solve poster steps. The first strategy to use is chosen for you, as the examples given are from that particular strategy. The strategies are underlined in this activity. The action words are shown in purple. At least one of the action words will match an action card identified for this lesson. Materials are placed on the table: cubes, attribute blocks, math line, and 2 containers. I chose a box and a paper grocery bag. Before teaching Think About It, you will want to prep for this lesson so your students can see exactly what is going on. This lesson involves hidden objects. Remember, some of my students may not have object permanence at this point. As I walk through problem solving, note that I am making everything very transparent. Certainly, I'm revealing the solution all through this process so students will get what I am doing. Place a set of cubes on the table. I can say, look at the cubes. See the box? Then cover the cubes with the box. I might even tell my students, look, I'm covering the cubes with this box. I place attribute blocks on the table. I can say, look at the shapes. See the bag? Then place the shapes into the bag. I can say, look, I put the shapes in the bag. The bag is covering the shapes. Place the math line on the table. Say, this is a math line. It's not covered. I can see it. Write the problem on the board. George has a mess. He wants to work on math. His tools are missing. Where are George's math tools? That seems a bit wordy to me. I can simplify the problem by reducing the language, but keeping the facts. Like this. George has math tools. The math tools are covered. Find George's math tools. Now that the problem is set up, we will begin with the first step, Identify the facts. What do I know about the problem? Read one fact at a time from the problem. You can highlight, circle, or underline each fact. Pair the fact with objects and/or action cards and write each on the poster. Let's see what this looks like for level 1 students. Now, in this particular activity, I am demonstrating to my students. That's what this activity is for. So I'm not asking for student input at this time, but if they do give me input, I will recognize that and talk about that. Mainly, I want my students to see this problem-solving process. I chose to identify the first fact. The math tools are covered. I need to show my students what I mean by that fact. I show the math line and say, this is a math tool. I can see it. It is not covered. Peek under the box and in the bag. Say, it looks like these tools are covered. They're covered by the box and the bag. And then I wrote the fact on the solve poster. Tools are covered. I now choose the second fact, which indicates what is needed to solve the problem. Find George's math tools. I say, this is a fact that tells us what we need to do to solve the problem. Find George's math tools. When I want to know where the math tools are, I look for them. Find the math tools means to look for the math tools. And I wrote the fact on the solve poster. The 3 action cards are placed on the table, as you can see below, for the next step in thinking about this problem. Number 2, choose an action. Now, this is the reason why we've been practicing the action cards every time we are reminded to do so that students are ready for this. Now, in this part of problem solving, this is essentially a first thought. What do I do to solve this problem? What can I do? You can change the action later. You may think through it further. Your students might think through it further and change their minds, and that's okay. If you change your mind, explain your reason for changing it to the students, but keep it simple. Say, I can show one of the math tools. I can show the math line right up here. Fasten show on the poster. Okay, so that's a first thought for me, is that I could show the math line because it's right there on the table. Say, I don't see other math tools. I can look for math tools. So here I have the word look and the word touch, and I'm saying I can look for them under the box. I can look for them in the bag. Now I'm certainly giving away the solution here, right? But I need my students to know what I'm doing and why I'm thinking these things. So I'll do that. I'll be very obvious why I'm choosing the word look, and I'll put it right up there, right up on the solve poster. Making a prediction, which is step number 3, is a reasoning skill. What is the most reasonable outcome? What will be the result of my actions? Now, the step number 3 also has the word estimate in it. We know that estimate involves an amount. We're not working with amounts here. So it is prediction. It's more of an action of what's going to happen as a result of my actions. Now, this can be a difficult concept as it requires some imagining. As a matter of fact, experiencing cause and effect would help students prep for this step. Let's make it concrete for level 1 learners. Show the math line. Say, this is a math tool. The facts say there are math tools, not just one tool. Show the box and the bag that have math tools inside. Say, the choice is we find just the math line tool, math tool, or we find 4 tools. There were blocks under this box. Shake the bag. I can hear some things in this bag. I remember there were shapes in the bag. I think there are math tools under the box and in the bag. And then write the prediction on the poster. I predict we will find math tools looking under the box and in the bag. Step 4, choose tools and strategy. It is simpler and more concrete to provide tool choices to represent the strategies. Say, I will choose how to solve this problem. Look under the box and in the bag, or look in another place. Write the tools or strategy on the solve poster. And before I do this, I'm going to want to explain to the students why I'm doing this. So I already showed them the tools under the bag or under the box and talked about the tools in the bag. And I can say, I don't see anything on this shelf. There's nothing here. I won't find tools here. But I remember there's tools under the box in the bag. So I choose looking under the box and in the bag. That makes more sense. Remember, we're looking for tools. Step 5 is the solution. Uncover the tools and write the solution on the poster. I looked under the box and saw math tools. I looked in the bag and saw math tools. So in looking at that, we need to keep in mind there's another strategy, right, that we need to complete. So we have rejected this strategy. Let's try this with that strategy now. So I'm going to keep the cubes and the shapes hidden and repeat with the next strategy, look in another place. So we'll go back to this, right, where we have everything hidden, and we'll say, all right, so we're going to choose looking in another place. What happened? And we can then decide which was the better solution, which one helped us solve the problem, which one helped us actually find the math tools. Looking at a spot that's empty with no tools on it, or looking where we know the tools are hidden. In the next problem on the same page, solve it together. You and your students are solving a problem together with your guidance. Kendra is getting ready for school. She wants to put her math tools in her backpack. She can't see the math tools on the table. Where are the math tools? As you guide the students, they will be making the decisions. This problem is very similar to the one you demonstrated in Think About It right before. They are using the same tools. Students have experience with the tools and concepts, so this will support them with this new problem. If you want to solve it together to be different from the first problem, you can change containers, right? We have these containers, right? You can change, for example, the empty place, right? The empty shelf, replace that with a large container with a lid on the table. Students will learn the solve poster steps over time. They will not get this right away. The key is to teach them, not test them. They're still learning this. Expect them to get this in no less than a year. And for level 1 learners, it is reasonable to expect they will get portions of this at a time. You may see progress in that students make reasonable choices for 1 or 2 of the steps on the poster. For students with significant disabilities, that would be an accomplishment and a notch up in their independence. On the second page now, you will begin with new vocabulary. In this case, it is the word math. We want students to have a visual and concrete example of what we use in math class. On the left, you see the vocabulary card. Next to that, a smaller vocabulary pick symbol to label the concrete connection. Objects for the concrete connection and a plastic bag. So we want the students to have a visual and concrete example of what we use in math class. There are shapes, cubes, and numerals on the table. Read the definition from the lesson, then students help you create the concrete connection. And then label it with the lesson pick symbol, or you could label it with the vocabulary card. The directions also include additional math tool examples with lines, numerals, dials, and buttons, for example, math line, scale, ruler, calculator, and so on. After new vocabulary is introduced, we move to think about it. This activity is a demonstration of problem solving using one strategy, then repeating it with the second strategy. So this is all you. You are demonstrating this problem to your students. Look at the solve poster questions in the upper right-hand corner. On the second page, you will begin with new vocabulary. In this case, it's the word math. Show the vocabulary card, as you see on the left. We want students to have a visual, but also concrete examples of what we use in math class. So you can see in the bag I've placed with my students shapes and cubes and numerals from the foam magnetic numeral set. And then label that concrete connection with a lesson pick symbol that matches the vocabulary card. Read the definition with the students and create this concrete connection together, as I said. The directions also include additional math tool examples with lines, numerals, dials, and buttons, for example, math lines, scale, ruler, calculator, etc. On the second page now, you will begin with new vocabulary. In this case, it's the word math. Show the vocabulary card. We want students to have a visual and concrete examples of what we use in math class to define math. There are shapes, cubes, and numerals on the table. Read the definition, then students will help you create the concrete connection. And label it with a lesson pick symbol that matches the vocabulary card. The directions also include additional math tool examples with lines, numerals, dials, buttons, etc. For example, math line, scale, ruler, etc. After new vocabulary is introduced, we move to think about it. This activity is a demonstration of problem solving using one strategy, then repeating it with the second strategy. Look at the solve poster questions in the upper right-hand corner. Now look at the numbered sections of this activity. You will see there is a description and example for each of the solve poster steps. The first strategy to use is chosen for you, as the examples given in this section for each of the solve poster steps are from that particular strategy. The strategies are underlined in this activity. The action words are shown in purple and at least one of the action words will match an action card identified for this lesson. Materials are placed on the table. Cubes, attribute blocks, math line, and 2 containers. I chose a box and a paper grocery bag. Before teaching, think about it. You will want to prep for the lesson in front of your students so they can see exactly what is going on. This lesson involves hidden objects. Remember, some of the students might not have object permanence at this point. As I walk through problem solving, note that I am making everything very transparent. Certainly, I am revealing the solution all through this process so students get what I'm doing. I place a set of cubes on the table. I can say, look at the cubes. See the box? Then cover the cubes with a box. Or I might even tell my students, look, I'm covering the cubes with this box. I place attribute blocks on the table. I can say, look at the shapes. See the bag? Then place the shapes into the bag. I can say, look, I put the shapes in the bag. The bag is covering the shapes. And then I'll place the math line on the table. And I'll say, this is a math line. It's not covered. I can see it. At that point, you will write the problem on the board. This problem is directly from the lesson. George has a mess. He wants to work on math. His tools are missing. Where are George's math tools? Now that seems a bit wordy to me. I can simplify, and you can too. Simplify the problem by reducing the language but keeping the facts. Like this. George has math tools. The math tools are covered. Find George's math tools. Now that the problem is set up, we will begin with the first step. Identify the facts. What do I know about the problem? Read one fact at a time from the problem. You can highlight, circle, or underline each fact. Pair the fact with objects and/or action cards. Write each on the poster. Let's see what this looks like for level 1 students. I chose to identify the first fact. The math tools are covered. I need to show my students what I mean by that fact. I show the math line and say, this is a math tool. I can see it. It's not covered. Then I'll peek under the box and in the bag. And I'll say, it looks like these tools are covered. They're covered by the box and the bag. And then I write the fact. Tools are covered under facts on the solve poster. I now choose the second fact. Find George's math tools, which indicates what is needed to solve the problem. I say, this is a fact that tells us what we need to do to solve the problem. Find George's math tools. When I want to know where the tools are, I look for them. Find the math tools means to look for the math tools. And I can write this fact on the poster. The 3 action cards are placed on the table for the next step in thinking about this problem. We're on step 2, choose an action. This is only a first thought at this point in the problem solving process. What do I do to solve the problem? I have some ideas here. You can change the action later as you think it through further, but explain your reason why you changed it to the students. Keep it simple. Say, I can show one of the math tools. I can show the math line. Fasten the word show on the solve poster. Say, I don't see other math tools. I can look for math tools and show how to peek under the box and in the bag for math tools. We looked. Right? That's what we can do. can look for math tools. I show one card at a time and demonstrate in the context of the problem. Will I be giving away the solution? Well, for some students, I might be doing just that, but the concept of a thinking process is very abstract. I need to show the possibilities of what I can do to solve a problem. This is an opportunity to see what problem solving looks like as concrete as possible. This part of the lesson is a demonstration. I make the decisions. Those decisions might be based on how much support my students need. So there is a third card there, but I don't have to use it. If you notice, the word touch is still there as one of the action cards. As a matter of fact, I could just use one action card if I wanted to keep things very simple. Because this is an early demonstration of problem solving, I would be sure to pick the action that would solve the problem at this point. So if I chose one card, it would definitely be the word look. Look for the math tools. Making a prediction is a reasoning skill. So in step 3, we are going to make a prediction about what the solution might look like. I would use the word estimate if we were working with amounts, but we're not. So we're making a prediction instead. That's based more on actions. What is the most reasonable outcome? What will be the result of my actions? This can be a difficult concept as it requires some imagining. As a matter of fact, experiencing cause and effect helps students prep for this step. Let's make it concrete for level 1 learners here. Show the math line. Say this is a math tool. The facts say there are math tools, not just one tool. Show them the box and the bag that have math tools inside. Say the choice is we find just the math line math tool, or we find more tools. There were blocks under this box. Shake the bag so you can hear some things in the bag. I can hear some things in this bag. I remember there were shapes in this bag. I think there are math tools under the box and in the bag. That's my guess. That's my prediction. And I'll write that on the solve poster. I predict we will find math tools looking under the box and in the bag. Step 4 is choose tools and strategy. It is simpler and more concrete to provide tool choices to represent the strategies. In this case, say, I will choose how to solve this problem. Look under the box and in the bag. Or look in another place. Write the tools or strategy on the solve poster. Nothing on the shelf, right? I'm not picking that one. I know that there are tools under the box and in the bag. So I'm going to write, I choose looking under the box and in the bag. Step 5 is the solution. Uncover the tools and write the solution on the poster. I looked under the box and saw math tools. I looked in the bag and saw math tools. Next, keeping the cubes and shapes hidden, repeat with the next strategy. Look in another place. This is followed by a discussion. Which strategy helped solve the problem? So I would put the box back over the cubes and the shapes back in the bag, and let's say, well, let's try solving the problem this way. Let's see if we can find the tools by looking in another place. And we chose, or we're going to use what we had, which was the empty shelf. What happened? What happened when we looked on the empty shelf for tools? Nothing happened. We didn't find any tools. We can have a discussion about what was the best way to find the tools in this situation, and so on. In the next problem, on the same page, solve it together. You and your students are solving a problem together with your guidance. So you're guiding the students, they're making the choices. The problem is Kendra is getting ready for school. She wants to put her math tools in her backpack. She can't see the math tools on the table. Where are the math tools? Now, again, you can choose a simpler version of that. And I can drill all this down to Kendra can't see all her math tools. Find Kendra's math tools. As you guide the students, they'll be making the decisions. This problem is very similar to the one you just demonstrated, and think about it right before. They're using the same tools. Students have experience with the tools and concepts, so this will support them with this new problem. But if you want the solve it together to be different from the first problem, you can change some things, right? You could change the box and the bag to a different container. You could change the empty shelves to another area, for example, a very large container with a lid on top. So those are basic changes you could make. If you wanted to go one step further, you could put different tools under the box and in the bag, different math tools. So in looking at those 5 solve poster steps that we went through, know that students will not get that. They will not understand that the first time around. They will not get this right away. They will learn those steps over time. So the key is to teach them those steps, not test them. They're still learning this. Expect them to get this, all of those steps, in no less than a year. For level 1 learners, it's reasonable to expect they will only get portions of this. You may see progress in that students make reasonable choices for 1 or 2 of the steps on the poster. And for students with significant disabilities, that would be an accomplishment and a notch up in their independence. In the latter portion of page 3, in Discuss, students take turns showing how they solve their problem and or how to check it. This can take any form that makes sense to the student, using appropriate adaptations if needed. Place math tools, counters, supports, etc. on the table for easy access. You'll also want to include the solve poster that the student used. There are 2 full-size solve posters included in the Equals Math Kit. In members-only content, in lesson prep, you will also find a smaller sized solve poster that you can print out as is and will come out as an 8.5 by 11 size. So each student could have their own, and that could be something that the student also uses to help show how they got their solution. But you want to have all the tools there, of course. Now, thinking about students at level 1, there are going to be students where that would be a lot to show. So you could simplify that solution and set up the problem. So you have, for example, cubes on the table with the box on top, and the student uses an adaptation to flip the box off to show that the tools were underneath, right? This is how I looked for the math tools. That would be an appropriate way to show how they got their, the student got the solution. In group problem challenge, this portion of the lesson allows the group to look at the problem, the same problem they solved on page 3, the same one that was just discussed, showing what they did to solve it. Allows the group to look at that problem, make a change, and see what happens in 2 ways. There's usually one irrelevant fact and one relevant fact. So when we look at group problem challenge, it says read the same problem, okay. What would happen, here's the irrelevant fact, what would happen if we changed the boy's name to Joey? Now in that problem, of course, we know that the solution would be to find the math tools. Changing the boy's name to Joey doesn't really change that. You could still find the math tools no matter what the boy's name was. So that really wouldn't have an impact. And we're going to have that discussion, talk about how that would change. What if we changed math tools to writing tools? And so that might take a little bit more effort, in that we would actually get some writing tools, put them on the table and say, all right, so if we said it was writing tools, would that change what happened? Well, sure it would. We'd have now all writing tools, not math tools present. So we would solve those new problems together, right? So for each of these, for the first one, for the second one, we want to have the solve poster there and walk through that process again. This is a nice opportunity to review that process one more time. And then we'll discuss each of the differences in the problems, and if the strategies changed, if the outcomes changed, essentially what happened. This, where we are here, where it says close, this is where close activities begin. First thing you'll do is to bring back Math Dash from page 1. Provide any added adaptations that have been included throughout the lesson, and observe changes in students' actions and understanding. So you're bringing all those materials back, you're providing the adaptations, anything that the student used to support them, so that you can see, is there a change in what students are doing, and are they understanding what's happening in Math Dash more than they did when they first encountered it on page 1. This is a good formative assessment, measuring the impact of the lesson on understanding the concept and actions in Math Dash, in their exploration of materials, and or the use of new tools and adaptations. Following Math Dash Revisited is, what did we learn? And there's 2 ways to approach that. I learned WorkMats and number notes. Students have the opportunity to show what they know and write what they know. So I learned WorkMats is about showing what you know with objects and materials from the lesson. Number notes is about writing about that, what they know. For students with significant needs, the lines can blur a little between the two, as typically students are concrete learners. That writing portion can be concrete. We'll talk about that in a minute, but typically isn't, right? So let's take a look at some examples so we know what that looks like. I learned WorkMats as well as the number notes pages are leveled to support students so they can show what they know. Level 1, I learned WorkMat, is on the left. First part says, what did you learn? Second part says, show it. The focus is mostly on lesson materials for students to use to answer the question, what did you learn? And then show it with chosen materials. So here's a concrete connection for the word look. Here are some shapes, a cube used in the lesson, and the concrete connection for the vocabulary word math. And students can choose those and place those, and I can make comments about it. I can ask the student questions. I can provide objects for them to choose to answer my questions however I want to do that. I want the students to choose what they want to choose, and then I'm going to support them so I can have them interact with those materials to see what they've learned, what they know. So for an example, is I could show both the look concrete connection and the math concrete connection, put them side by side, and ask the student, show me the look concrete connection, and see what the student does. Right? I can have the math materials on the table here, just like the student chose them, to put it in show it on the I Learned WorkMat, and I can say, find the math tools and see what the student does. Now we have math tools in the bag and we have the math tools here. So maybe I could add something else over here, like an empty box, which are the math tools. So I can bring the student in that way. Student makes the choices, I can ask the questions. So a video showing the student in action during the lesson is a good idea. For example, what I described before, a student moving a box to find the tools. So if you're having a hard time with the student showing what they know using the iLearn WorkMat, you could substitute with a video of the students with the materials in front of them. Could be a video that was completed during the lesson or later on in the, right when there's problem solving or later on in the lesson. And that short video can be shown at this time, right? When the students are talking about their iLearn WorkMats and we're showing them to the group, maybe it's showing that student's video, then talk about what's happening there. I could take photos of individual students in class and fasten it to the iLearn WorkMat to show what the student is doing. We can display it in school and eventually send it home. Number notes are used as a written record of what the students know. This is an opportunity for students to communicate what they have learned or how they solved a problem using vocabulary cards, action cards, finishing a closed sentence with a pick symbol, a lesson pick symbol, showing vocabulary. Here's the word math, maybe even writing the initial letter of the vocabulary word. That's a nice inclusion of literacy there. Photos from class or demonstration can be used on number notes or a description written by the teacher and is read to the student. Number notes can be displayed or sent home. Throughout this process, it's good to remember the Action Dictionary, where you can look up adaptations for the word write, record, draw, and so on. The last page of the lesson, page 4, is all about practice and application. It is important when teaching to cover all activities in order as shown on the first 3 pages, 1, 2, 3. However, when you get to page 4, now you have a page of choices. You may choose which activities, how many activities, and how often the activities are completed. Base your decisions on what you know about your students, their specific needs for learning, practice and application, and their interests. Let's take a closer look at what these are. The first activity is sensing math, and I can see that there are 3 options because I have 3 bullet points here. The first option is to chant together. We use math. Yes, we do. We use math. How about you? Students can clap or stomp feet with the chant or use the step-by-step to record each line separately so each student gets a chance to say a line. You can find adaptations for clap and stomp in the Action Dictionary that are cross-referenced to chant, act it out, and play instrument. When you are looking for actions, look in the table of contents of that document first, because if there isn't a page specific for an action you're looking for, you will find it more than likely listed there, and then you'll see what is cross-referenced to. So you will see clap and stomp, but you'll see a cross-reference to chant, act it out, and play instrument. The second activity is focused on exploring math tools on a table or in a center. This activity specifies that this setup can be present throughout the lesson. Okay, so these are just placed in an area, whatever you'd like to place there for the students. The third activity involves a sensory table if available, placing a variety of tools under or in containers for students to explore. I would say either or could be used throughout the week. I would actually prefer the one where students are searching in boxes or bags or containers for objects to get the idea that something could be hidden in there, right? Where are the hidden math tools? In real life problem solving, there are 3 categories: classroom connection, content connection, and common connection. And this is a very valuable place where students are connecting what they're learning to the real world. So the first category is classroom connection, and that's utilizing classroom tools, math tools, for, in this case, a scavenger hunt. Take photos of equals math tools. Here's a photo of a turtle. And then show one photo at a time so the students can locate the matching object in the classroom. Could be on the table, could be in the cupboard. They might have to search for it for a while, however you'd like to work that. You do have the option of using a duplicate of that object, a double, right? Instead of the photo, if you have a student who's not really understanding the photo is representing an object. Next, content connection links the math concept to another content area of math or to another subject area, science, could be a book we read, etc., or the web on the computer. In this case, it is connected to counting. So that would be the content area of numbers and operations. So what you would do in this activity is use Velcro to attach 3 cubes to the step-by-step communicator, and then record 1, 2, 3 for the students to count sets of 3. Here are 3 cubes for them to count. Common connection connects the math concept to the larger school space. For example, the library, office, lunchroom, halls, gym, or it could be to the community. In this case, it is the school office. So students go to ask office workers about the math tools they use, okay, and write a list or take photos to discuss back in the classroom. So here's our list, and we can talk about what those tools are used for. In partner problem solving, there is a problem solving template, here it is, based on the problem solved in the lesson. There are 3 levels of materials for students with level 1 needs, significant needs. Choices are simpler with fewer choices than the other 2 levels. So this is the level 1 template. This problem is blank, that's a person, wants math tools in the backpack. Which are the math tools? And then there's 3 spaces for answer choices. So that's what the students need to do. They need to write their own problem here, essentially. Students love this. This is really a lot of fun. And we have the pick symbols here to help them do that. For example, for the person here, we have 4 choices. The students chose, let's say they chose Chandra. Pick symbols can be difficult to handle for students with motor challenges. So it is recommended that for this group of students particularly, pick symbols are secured to a hard surface that can be moved. For example, a cube from the building block set. So we have Chandra filled in as the key person in this math problem. And then we need choices below, because the question is, which are the math tools? So it could be a mixture of math tools, not math tools. Let's say the students chose scale, dog, and math line. Now the problem is then exchanged. Now to exchange this, I could put this, because it has the cubes on it, I could attach the cubes with tape, like just roll up some tape and put it on the back of these, place it on a tray so it doesn't fall off. So the black tray that's included in your kit would be useful there. And that problem could be exchanged with another partner pair, given to the teacher to solve in front of the class. The students could solve it themselves, or they could solve it together with the whole group. So a lot of options there. Finally, there are 2 games. Look What Is It and Look Lotto. Look What Is It is basically this game that uses a spinner to determine the tool to look at and then remove the image or the double tool from the spinner until there's a winner. Look Lotto is similar to bingo. Cubes are used as bingo chips. Both games include looking at math tool images. However, I would include the actual tools in the first game, Look What Is It, as described, and also for reference in Look Lotto. And that is the end of page 4. A lot of options there for you. If you are a creative person and you enjoy coming up with games, fun activities to reinforce the math concept, I encourage you to do so. The only thing that you need to do is to stick to the lesson objective as written and continue to use the actual math terminology, including the vocabulary words, the action words, math tool names, so that that's consistent for the students. But if you want to come up with your own game or an activity that you think is fun, that's part of the joy of teaching. A lot of teachers love doing that. I know I did. So while working on the activities on that 4th page, it's a good time to send the 1A, so that's for section 1A, home letter to the parent or parents. You will want to select the activity that focuses on the current skill taught. So for lesson 1A1, it is attending to math instruction. And that was represented in the lesson by using math tools. So to assign an activity, I would mark on the paper, circle on the paper what the student should do. The most logical activity, I think, to assign as homework would be exploring math tools at home. And another would be using the Look vocabulary card that's included to attach to a mirror at home to reinforce that daily, right? And that's listed up here with the other assignment that I marked. That concludes our webinar, Support for Students with Significant Disabilities. If you have questions, contact AbleNet Customer Service, toll free 1-800-322-0956, local 651-294-2200. There is a teacher support link, equals resources page at ablenetinc.com/curriculum-resources as shown on the screen. You can find links to pre-recorded webinar training, equals technology lesson center access, standards alignments in a new format, members only digital content that is updated, and a second folder, additional members only digital content, equals frequently asked questions, and more. Thank you for your time.